Hi, good morning everyone. Welcome everyone to Fit 5136. This is the week one, the first week of the unit, right? And then today we're gonna give you an introduction to software engineering. Basically, I will give you like more details about what is the purpose of the unit, what is the learning outcome that you will get, and that kind of thing. Okay. So maybe first of all, I just want to introduce myself. My name is Kla, Dr. Kla Tantitam Thawan. So I am the chief examiner and also the lecturer for the whole unit as well. And within this semester, we have roughly 300 students, and we have also 14 apply sessions. So we need lots of support from the TA, and these are the list of the tutors or the TA that they will work closely with you. So we have Max and Shiming, who are the head tutors of the unit, and we have Vanita, we have Chan, Michael, Ian, and Anthony. So if you have enrolled with the right time slot, and then you will meet one of them here. And just in case if you have any questions about the unit, right? So please mainly use the ED discussion to discuss about the assessment and that kind of thing. But if you have some concerns or questions around about with the admin TA, so please try to using this email row account fit5136.clayton-x@monash.edu. Okay. So again, to communicate with us, there are two options. First, using the ED discussion, and that will be the general questions, that kind of thing. But if you have some like a major question with the head admin tutor, please try to send an email to this one. Avoid sending an email directly to me because it will be a little bit hard to answer. Basically, the head tutors will handle most of the email questions. Okay. All right. So for this unit, right, the purpose of this unit, we these are the unit learning outcome, and basically we want to ensure that by the end of the completion of the unit, everyone will be able to understand and describe what is the software development life cycle. So basically we design the whole unit to align with the software agile process methodology. All right, so we normally start from the requirement gathering. What is the technique to elicit the requirement, that kind of thing. How can we design the software, the class diagram, that kind of thing effectively. How can we develop the code, test the code, deploy and maintenance, that kind of thing. And for the second learning outcome, right, so some part of the unit we will learn about how can we design and document the software architecture using lots of UML diagrams as well, like a sequence diagram, use case diagram, that kind of thing. And then once we learn about software design, then we need to implement it as well, okay, using the object-oriented programming. And how can we ensure that the software is functionally correct, right? So we need to apply some software testing strategies. So we will learn a lot about the software testing. How can we design the test cases? How can we execute the test cases? What is the unit testing, that kind of thing. And in terms of the assessment, we will work as a team as well. So the first three assessments will be the group projects, and the last one will be the individual one, okay? And you know, the most important question here is how can we ensure that the software is ethically aligned and it is responsible to the society as well, right? So we will learn about the ethics, about the intellectual property, the privacy, security, that kind of things, okay? We want to develop the software for the humans, so it should hold some responsibility as well, okay? Yep, and as I mentioned to you before, we the content of the whole unit is actually designed to follow the Agile Scrum project management. We split the content into 5 modules here, and basically there are 12 lectures, okay? And the first week, the week one, right, we will talk about the introduction to software engineering, which is the high level here. And we will give you some intro, what is the software engineering, what is the software process. There are different types of the software process, like waterfall, agile, and open source software development, that kind of thing. And there are different types of the agile as well, like Scrum and Kanban, that kind of thing, right? So we'll talk about that in details. And once we get into the agile Scrum project management, we'll start as part of this Scrum, right? We will start from the requirement engineering. As a product owner, you need to elicit the requirement, whether it is functional or non-functional, and you need to break down. We cannot develop software like for 10 years, right? We need to finish everything in a short iteration. So then we will learn about how can we manage the project effectively as well. We elicit the requirement. There are different techniques to elicit the requirement. We will learn about that. And then once we get the requirement, we will learn about how can we create the product backlog. These are the to-do list, that kind of thing. And then for each iteration, we will execute it. We will talk about that part as well as a sprint. And then we will talk about how can we conduct the agile ceremonies, like daily stand-up meetings, sprint review, sprint retrospective, that kind of thing, or the end of the sprint. Okay, there we will talk about different roles within the agile project as well, like product owner, the development team, the scrum master. What are the roles, what are their main functionalities, whether they follow what are the things that they need to do, right? Okay, and then we will talk about the software quality and testing as well. And to follow the agile Scrum project management, right? So we design the learning content like this. For the first week, it will be about the intro to SE, which is this week. Then followed by the agile project management, requirement engineering, requirement analysis, software design modeling, introduction to software quality and testing. We will learn how to write the unit testing, what is the code coverage, how can we conduct the code review effectively. There are different types of the software testing strategies, like black box testing, white box testing, how can we run the CI/CD. And then there will be a mid-semester break, okay? And then after the break, we will work on we will learn about the software engineering ethics. And the last two lectures are very important. Basically, we are in the age of the generative AI, and then we will talk about how can we leverage the AI, okay, the AI technologies to help software developers, right? And that's the content for the week 11, okay? And for the week 12, it is also exciting as well, because right now we are moving from traditional software development like website, static website, or just traditional one, to more like intelligent software. Think about the license plate recognition, computer vision, image detection software, fruit classification, that kind of thing. So and then when we develop the AI software, the algorithm is just like the small tiny part of the whole system, right? We will need to think about how can we deploy and manage the AI software at scale as well. So it requires lots of software engineering expertise. And for the week 12, we will learn about that as well. How can we, what is a software engineering for the AI software system? How can we engineer the AI software system effectively? Okay. Yep. And in terms of the assessment, okay, we basically have 4 assessment. The first one, all right, we call it A1, okay. We will release the assessment instruction on week 2. So it is a group work, and it is weighted 15% of the whole mark, and it will be about requirement gathering, analysis, writing the user stories, that kind of thing, and it is due on the end of the week 4. Should be the Friday week 4, okay. It is due on Friday week 4. And then for the week 5 workshop, everyone will need to do the presentation, okay, about the A1, the assessment one. And at the same time, the A2, it will be the A2 instruction will be released on week 5 as well, which is also, again, it is a group work. It is weighted 15%. It is about software design and modeling. How can we design the class diagram, design the use case diagram, that kind of thing, And then for the A2, which will be released on week 5, it is due on week 7. All right. So basically, students have 3 more weeks to work on the A2. And once you submit the A2 on week 7, week 6 we will learn more about the software quality and testing. So week 6, 7, 8, 9 they are all about software quality and testing, all right, and which is and they are designed to for the assessment for here. Okay, A4 is about software quality and testing. But anyway, okay, go back to the week 7 a little bit. The week 7, this is the group project again. It's about software development process and the artifact, right? And it is weighted 40%, and it is due during by the end. You need to give the presentation, the A3 on week 12 as well. That's the project presentation. So let me put this way. What we mean is that we're gonna give you the one business, one client requirement, okay, and in general around week 2, and you will work on the business requirement here. It is really designed for the A1, A2, and A3, so it is all together. It is a group project. They will work together based on the requirement. We give you one requirement, and then you analyze the requirement, decide the class diagram based on that requirement, and develop the code, develop the software based on that requirement as well. And this is a group project, okay, which is around in total, okay, 70%. And then for the A4, this is the individual work. It is weighted 30%. It is about software quality and testing. We will consider A4 as like a midterm take-home exam, that kind of thing. So basically, we're gonna give you another requirement as well. Students have to develop the code on the ED STEM, write the test case, run the code coverage, that kind of thing. Make sure that the code is functionally correct, and everything will be marked via the ED STEM. So everyone have to work on this, and you will have 3 weeks to complete between week 9, the mid-semester break, and the week 10. Okay, and yep. And that's all. Okay, any other questions about in terms of the assessment? And just want to emphasize again, there is no exam for this unit, so we will gradually, assess the student throughout the semester. Yeah. Any other questions around the assessment before I move on to the next slide? So A1 is presented in this class? Yes. No. Oh, sorry. A1 will be presented in the apply session. Yeah. And same to the A3 as well. So any presentation will be conducted during the apply session, your own session. Yeah. Not in the lecture. So we have to develop a software this semester. Yes. And the software will be something very lightweight, we actually expect just a text-based programming. So it doesn't need to have like a fancy UI, that kind of thing. Yeah. Which language? Very good question. So we're gonna have I will talk about that in the next few slides as well, but in short, it will be either Python or Java. Yep, either one of them. All right, thank you for your question. Okay, and then I'm gonna move on. Yeah, do we need to do presentation in person or video recording? Yeah, only in person. Okay, yeah, we do not accept video recording. All right, I'm gonna move on. So in terms of the lecture, the lecture for the unit, it will be online only via Zoom. So I'm pretty sure everyone here already know how to attend the lecture because everyone is here. Okay. All right. So we will use Zoom. It lasts for 2 hours, and then everyone will have to attend the apply session as well. It is the 2 hours tutorial every week. So everyone should participate as well during the apply session. All right. So in total, for this unit, it requires roughly 12 hours per week. Okay, to complete the whole unit. So the workload is quite, on average, it's not really a lot. And for the last semester, students are quite happy with the unit as well. Yeah. And because we have assessment, that kind of thing, what I need to emphasize is about the cheating and the plagiarism, right? um, I would say that try, it's not try, like you should not do anything about the cheating or plagiarism. Try to make sure that you conduct the work by yourself, because this is an opportunity to learn. If you copy the code from someone else, you get the degree anyway, but you don't learn anything, so it's kind of like a waste of money, right? And then I would like to emphasize that every submissions that we receive, we apply the plagiarism checker to check the similarity. We analyze the similarity report of the submissions between the groups across the whole cohort, that kind of thing. So if we detect any similarity, we will apply the penalties, okay, according to the university policy. So there's no question asked, all right? We will just need to report anyway. And the worst thing is that this kind of record is kept within the university, right, for up to 7 or 15 years here. And when you apply for the job, there's a higher chance that they may check for they may do the reference check with the university, that kind of thing. And we need to provide that kind of report as well, which is not good. It may appear in your transcript as well, so try to avoid. And I hope that I will not see any plagiarism or cheating cases within the unit at all. Okay, avoid as much as possible. In terms of the ChatGPT, I understand that everyone can use ChatGPT. For some of the assessment, it should be avoid because if you use ChatGPT, then we cannot really understand whether you are capable of doing coding or testing, that kind of thing, or not, right? And yeah, there is a higher chance that if you use ChatGPT, it may return the same answer for everyone, right? And then what happened is that there is a higher chance that lead to the plagiarism as well, because the code that is returned by the ChatGPT is similar to the other student who use it as well, And just want to emphasize again that we also apply the AI code detector here as well, just to make sure that the code that we receive from the student submission are not from the ChatGPT, that kind of thing. So yep, try to avoid using this kind of technology as much as possible. What I mean is that we encourage you to use ChatGPT to learn the concept of the unit, right? But for the assessment, I would recommend that you should avoid. Okay, in terms of the programming languages for this unit, every student should use either Java or Python. Other programming languages are not recommended because it will be a little bit harder to mark as well. But because for the A1, A2, and A3, the first 3 assessment, it is the group work to decide which programming language that you want to use. You may want to discuss among the team members, right? So for the group, for the team forming, we will provide the instruction later as well, how to create the group, okay? For this unit, there are a few tools that everyone need to use. So for example, we will learn how to use Trello, how to use GitLab, how to use the Lucidchart, and probably you can use the Google Drive for the documentation as well, collect the report, that kind of thing. And because it is a group project, right? How can we ensure that everyone contribute equally? So we're gonna use the feedback fruits for the peer evaluation as well. Yeah. In terms of the learning resources, right? So everything will be available in the EdSTEM tutorial and everything. So we actually mainly use the EdSTEM for the learning resources. And for the assessment, it will be submitted via the Moodle, okay, for the A1, A2, and A3, but only for the A4, okay, it will be on the EdSTEM. And if you want to have access to the lesson content, just go to this link, or in the EdSTEM, you just go to the second button, okay, yeah, which is lesson here. All right, and what else? Okay. All good. Any other questions? Then otherwise, we will do some interactive question a little bit, okay? And can you please go to the polev.com/fit5136. So this is just like, we just want to get to know to each other a little bit, right? Like, yep. Just want to check if everyone can access the poll everywhere or not. Can you try? Just want to check if everyone can access or not. I'll go to this link. Yep. Here we go. Do you need to register? Yes. So basically that will be 4 or 5 questions, okay? Just a basic question. We just want to learn more about you. So we have 37 participants today. Yep, I should expect at least 30 response. We have 3 students complete the survey already. 16 is underway. Really, thank you so much for your active participation. This is really lovely, Thank you. "15 surveys underway." I will wait for you for the other 7, 8. Yep. Okay, I'm aware of the time. Maybe maybe I will present the results of the survey a little bit, but for those who is working on it, just keep working. Yeah, no worries at all. Okay, for the first question, I'm not too sure what happened here. Respond. Oh yeah. Okay. Okay. What is the most preferred programming languages? And yeah, it seems like Python seems to be the most preferred programming language, which is good. And followed by the Java. Okay. Either one is fine, which is good as well. Yep. Next. So just want to check if what is a student background for who enroll in this unit, right? And it seems that the majority of the student roughly how can I say, just start the software engineering career at Monash University, which is a good thing. That's why everyone really wants to enroll in this unit, right? Yeah. Yep. But for some of the students, they are quite experienced already. Yeah. Okay. Have you learned about software engineering before? Yeah. Most of the students they don't. Okay. Which is good. That's why everyone enroll in this unit, right? And I'm pretty sure that yeah, you will have the best learning experience about software engineering, yeah, from this unit. Yeah. So the next question, the last one, what is the most preferred content in SE that you really want to learn? In general, it seems like yeah, everything is about software engineering. Yeah, they are quite important, right? So yeah, software testing, software quality. Yep, thank you. Yep. So we will cover all of this, yeah, in the next few weeks anyway. Yeah. QA, design, requirement gathering. This is so important, People often ask like whether AI is going to take the human job or not. No, actually not, right? So what I would say is that AI only replace the task, not the job. Despite the AI can generate the code, but as a human, as a person, we still need to ensure that the quality of that software system is also correct. So software quality, software testing, code review, how to review the code, how to design the code, how to analyze whether the code is actually in a good design or not, that kind of thing, it's still important, and it requires a human. Yeah. Okay, thank you so much. Yeah. Yep, that's right. High quality and reusable code. Yep, thank you. Okay, so I'm gonna go back to the lecture now. All right. Yeah. Okay. So right now, we are moving towards the digital world, and most of the organizations, they are doing lots of digital transformation. They want to adopt lots of new technology. They want to transform the organization into a data-driven, so that they can make the decision based on the data, that kind of thing. They want to build the smart organization using lots of Internet of Things. Lots of automation in the industry as well, and the AI definitely, right? So with lots of digital transformation here, right? So software engineers actually plays an important role to enabling this kind of transformation by creating the software system, enhance the business operation from e-commerce platform to online banking and the telemedicine. So software engineer is actually go across all of the domain and the sectors at the moment. Think about the banking system, right? Like in the past, we use like a human or the staff at the branch, that kind of thing. But nowadays, everything becomes like an online banking account. We use the mobile phone. So software engineering actually plays a more important role, even like nowadays. Yeah. So, and there are different types of the software system in across different sectors like healthcare, financial sector, e-commerce sector, transportation, education sector. Every companies right now become like a software company. Think about like, transportation like Transurban, Link-T, or Jetstar, Qantas, these kind of transportation. They use lots of software to manage the reservation, operation, manage everything, right? So, but the key question here is that we can develop software, for how many years whatsoever. But the key question is that how can we develop or ensure the high quality of the software system that also meet the needs and the requirement of the user, stakeholder, and the organization at the lowest cost. This is the ultimate question. Why do we need to learn about the software engineering, right? Otherwise, everyone can program. Everyone can write the software, but how do you know that that kind of software system is actually of high quality, right? And once you develop the piece of software, how do you ensure that actually that software that you develop actually meets the client requirement? And and the last important aspect is about the cost, right? We cannot develop one software system for 10 years. That's almost impossible because we need to keep up with the demand. We need to release the new feature as soon as possible. How can we minimize the cost of the software development, that kind of thing? So that's the key question, why do we need to learn about software engineering, right? But to learn about software engineering, right, is actually, this term was first coined by Margaret Hamilton, the lady here who met with the President Barack Obama, okay? So this term was coined in 1963 at NASA when she worked at NASA, okay, as a staff, as a system engineer, developed some computer programs, right? But at that time she felt that the work that and her team did, is really as important as the engineering work when they developed the Apollo spacecraft. Apollo, there's a spacecraft, there's a engineering work, mechanical, electrical, whatsoever. But there are lots of software components inside the spacecraft as well. The button, how to turn on the engine. Once the engine is turned on, how to move the wings, whatsoever. I'm not in that area, okay? But there are lots of software components here. How can we ensure that each of the components, the wings move correctly in the right angle? That functional is actually correct, right? And how can we verify lots of components inside the spacecraft? So what she do, okay, whatever what she did at that time, she felt that this is really about software engineering. It's not about software development at all. That's why she was the first person to coin software engineering. And there are lots of questions that we received over the past few decades as well, like what is the difference between the computer science and the software engineering, right? And the key question, the key answer here is that when we talk about the computer science, it's actually focused on the theory, the fundamental, how can we design the data structure. Yeah, some student mentioned about the abstract data structure, talk about the algorithms, that kind of thing. That's actually part of the computer science, We talk about the fundamental, but when we talk about the software engineering, it's about how we build things in a more engineering way. We apply the engineering principles to create software. Think about civil engineering. They want to build the building, skyscrapers, build a bridge, that kind of thing, right? They need to elicit the requirement, what kind of building that we are going to build, how many bedrooms, how many rooms, how many floors, what is the foundation. They need to decide the architecture of the building. They need to test the building, whether like stress test the building, whether they can sit against the wind or earthquake, that kind of thing, so same to the software engineering discipline. We are doing the same, to design the software. How can we elicit the requirement from the end user, from the client, how can we design the architect, the enterprise system of the software system, how can we develop it in a team, with hundreds of developers, hundreds of software engineers. Think about Google. Right now they have more than 10,000 software engineers. How do they work together in just one single repository? And then how can we test it? How can we verify it? How can we deploy it, right? Yeah. Okay, and it is so important, right? When we talk about the software engineering, because if we don't develop well, it is actually fail. And yeah, these are just only 2 examples. Like in the past, this is the MyGeek system. It took like 7 years more than they planned. Okay, they planned to deploy the MyGeek system, but it took like 7 years delay, and they actually spent 55% more than the budget, right? And what the problem is that at that time they work as a team, but they don't have a clear divisions of the responsibility. They lack of expertise and that kind of thing. And they have a vague system specification, which later on is called scope creep. They thought that this is what we need to do. We need the machine, ticket machine. We need the rails. Okay, but they don't look into detail, and that's why everything is over the budget. And right now MyGeek still has glitch, right? So yeah, sometimes when you want to travel via the train, but you cannot because of the software system failure. And this is just an examples of the bank as well, right? Sometimes CBA or I should mention about the CrowdStrike. Anyone heard about that? Okay, so that's the global IT outage on the last Friday, right? And when the system is outage, then what happened is that you cannot even log into the bank. You got the BSOD, blue screen of threat, for all of the machines that use Windows, that kind of thing, and then you cannot purchase anything. And then they will just leave a customer hungry at home. At Woolworth you cannot shop or anything. You need to use cash. But let's say if the ATM got outage as well, then you cannot even withdraw a cash. So that's why software engineering plays an important role here, and there are lots of application, lots of research, lots of design principles, development principles that we need to learn, right? But when we talk about the good software, what is the characteristic of the good software system, right? And these are some of them, okay? First, it should be maintainable. What does it mean by maintainable? Let's say 1 year, the first year you develop something, and then you deploy, but the cost of the development is just only 1 year. But the hardest part is that you want to use that system for another 5 years or the 10 years, right? How can we make sure that software is adaptable to the client needs, that kind of thing, which is hard, to develop a more maintainable software system, right? Software should be dependable and should be highly secure as well. Think about the CrowdStrike case study as well, right? It is failed because some of the glitch in the CrowdStrike software. The software should be work efficiently as well. It should not consume lots of memory or processor, right? It should work on real time, be responsive with the little processing time, that kind of thing. Yeah, and the most important thing, software is developed for the end user, for the client. It must be acceptable by the end users. If we develop a calculator application but no one uses it, this is not acceptable, then how can we ensure that, how can we call it this is a high quality software system? Is that good? No, right? Yeah, because it's not usable at all. So these are some characteristics of the good software system. All right, but to develop a good software system, it is actually it depends on the 3 aspects here. The 3 most important aspects. Okay, it's about the people who develop the software system. Okay, and people here, it's about the team, the development team, the organization, the leaders of the team, the leaders of the organization, the culture, the client and the end users, right? So we need to look after these people, these stakeholders. We need to take care or incorporate all of that idea, knowledge into account so that we can develop the best software system. Okay, but even if we have good people, right, it doesn't mean that we can develop good software, because if the process is poorly designed, poorly set up, in the past we often use waterfall, which is like a sequential. We will talk about that as well, but it is not really adaptable to change. That's why nowadays people often use the agile software process instead, right? Even if we have good people, we have good process, we also need good technologies as well. If we choose the right platform, if we choose the wrong platform, wrong programming languages choice at the beginning, maybe we may end up with poor software development process as well. So that's why people, process, and the technologies are the golden triangle that lead to the best software system. Okay. Or I often call PPT. Okay, people, process, and the technologies. Okay, what is a software process? This is the same step as civil engineering, or let's say when you want to build something, right? First thing first, you want to elicit the requirement. This is the four general software process. Okay, by the definition, it stands for a structured set of the activities required to develop a software system. Okay, this is in general. We have only 4 steps. We elicit the requirement, define what the system should do. Then once we know the requirement, analyze the requirement, then we design and implement it, right? Define how the system should do, implement the system, and then the last, the third step is that we need to check whether this is something that customer really want or not. We need to do some verification, validation. There are different techniques to do about software and system verification, validation. We'll talk about that later as well. And the last step, we will not develop software system that use just only 1 year, because to develop one software system, it is quite expensive, right? Think about let's say you set up a team, you have 4 software engineers work together. Each software engineer costs 100K salary per year. This is like 400K already, plus others, right? So like 500, $500,000, right, to develop one software system. Okay, so that's why you need, like, you need to make sure that once you develop one software system, it should be very easy to maintain. It should adaptable to change as well. Yeah. Okay. The reason, one of the key reasons why we want to make sure that everything works effectively, efficiently. Why do we need the process? Because everything is about effort and the cost. We don't want to develop software for 10 years or 20 years. We want to release the feature within 3 months. It is the sprint. We need to fail fast, test whether the feature actually works in the market or not, right? Okay, so yeah, cost is the main concern. That's why we consider everything as the economic aspect, right? Because the software cost is actually greater than the hardware cost. Think about, you develop the software system based on the example that I tell you before. For software developers, it may cost like $500 million. Sorry, 500,000, $500,000, right? But think about the cost of the PC or the server to run the software. It's just like 100K or 20K, or just like one VM virtual machine, one instance in the Amazon cloud, which is like 1,000, But the software development costs $500,000. It is so expensive, right? That's why we need to manage people, manage everything effectively. Otherwise, it's just a waste of money, which is not a good thing. Okay, and that's why to ensure that software is developed at the highest quality with the lowest operational cost, we need to have a systematic software development approach. And there are different approaches as well. It really depends on the organization. Some of the example could be plan-driven process, like waterfall, rapid prototype, or the other model is like incremental software development, agile methodology, or the open source software development as well. Okay. Right. Okay. So plan driven, right? What does it mean? It means that the process is driven by the plan. Okay, that's a very simple word. Everything is quite systematic and rigid. For example, one of them is the waterfall, right? First, we elicit the requirement from the client. That's the requirement phase. We analyze the requirement to identify or determine what the product is supposed to do, and then we design, right, how the product does it. What are the features? What are the sequence diagram? How the user interact with the app, that kind of thing, you know. And then we can code and integrate the components all together. We maintain and deploy, that kind of thing. This is a waterfall, very, very sequential, you know, and it is quite plan driven because everything need to be planned in advance. Back to the figure here, right? You plan at the beginning what is the requirement. You plan about the analysis, what you plan what feature need to be delivered first, you know. But once the plan is concrete, then let's say tomorrow customer say that, hey, look, you know, I don't want this kind of calculator application. We need some more, we want more features around scientific calculators as well. You know, add more buttons, features, scientific features, that kind of thing. And then when the plan is concrete already, it's a bit hard to change. No, that's the downside of the waterfall. Okay, so that's why, and one of the problem is called moving target as well. That's the requirement change, right? As software is produced, waterfall, let's say it's a 1 year software project. You use waterfall, the technology change every day, 3 months pass, you want to change the requirement, it becomes very, very difficult to change the software design and analysis, everything, when using the waterfall model. Okay, so that's why nowadays they are really not use the waterfall unless they have a concrete requirement. Okay, you know, so that's why in the past, you know, waterfall is not really adaptable, right, to the requirement change. And people also create like an adjustment to the waterfall as well, where they create the new box here, change requirement. So each of the step, when they have requirement change, they can go back to the loop again. Okay, let's say let's say post delivery there's a requirement change, they need to go back to the analysis again. But what happened is that, you know, it delays the whole process, right? Because we need to go back to the beginning of the step, right? Requirement is changed. Okay, we start from the software analysis again. What is a new functional requirement? What is a new non-functional requirement? Is there any design that we need to change or not? Any class diagram, any object that we need to modify? We need to repeat everything, every process again, which is really time consuming and costly. Okay, and you know, and when we use the waterfall model, it is really documentation heavy. We need to have the software requirement specification, or people call SRS. Once they write the requirement, when there is a change, they need to change everything, right? UML diagrams, if it is very big, very large, if they change the requirement, they need to change everything. So one requirement, one single requirement change will actually impact the whole documentation process, the whole specification process, the whole software development process as well. So that's why software engineers are so afraid of the software requirement change, right? But that's the real world scenarios. But you know, we cannot escape from this, right? Because requirement change happens all the time. We need to adopt it. Okay. This is the why software is really different from the traditional software engineering. Think about, you know, when you build the cars, okay, or the building, when you want to create a building, right? when you do in civil engineering, it is actually like the same as the waterfall model. You get the requirement, you build the bathroom, you build the bedroom, you build everything, you build a house, but everything becomes more expensive if you want to change something, right? Because the foundation that they pour the concrete, that kind of thing, is already there. You cannot like, at the beginning I want to build 1-story house. Tomorrow I want to build like story house, which is impossible. It has to go to the council approval, that kind of thing. But software, it is different, right? We need to adapt to change, okay? And requirement change all the time. And these are the two key challenges of the waterfall model, okay? Requirement, the first one is about the requirement. The second one is the detailed documentation. And these are the two killers of the waterfall model. That's why, nowadays people really want to focus on the rapid development, rapid prototyping, software development. And this kind of process is widely used in the startup software companies, because when we build a startup software system, startup companies, right, we want to make sure that the idea, when we create a software startup company, okay, we want to turn the ideas into the reality as soon as possible. Turns the idea into the market as soon as possible. We want to test, right, whether the idea, let's say we want to develop one software system, whether that idea is actually good or not. But the cost of the whole software development process, it is actually expensive. What happened here is that they just create a prototype using like Figma tool, using anything like a mockup, to simulate how the system actually works, right? How the client or how the end users will interact with the software system, instead of writing the textual documentation. Because when a client read the textual documentation, as an end user, software should do like this, A, B, C, D, it is really hard to imagine how does it look like, right? But when you do the rapid prototyping, basically you create the real world prototype using the Figma, okay? Figma tool, and then how the UI looks like, what is the best user experience, when using this product, and then you can test the market easily, quickly as well. And to create the prototype, maybe just only one person, right? One person to work on this one. You really don't need like whole software development team, okay? And the process to create the rapid prototype here is that first we create the prototype, we review, and then we refine and iterate, okay? This is a whole process. It doesn't require the documentation or that kind of thing at all, because the prototype itself is actually the documentation already. This is the end product. We think about what the end products that it should look like, okay? But even if we use the rapid prototyping, requirements also change again, we cannot escape from this, So there are some other process as well. It's called incremental software development, right? So that means we basically, first we create the outline description, okay? And then there will be another 3 sets of the concurrent activities here, okay? Once we have the outline description, then we create a specification, we develop something, and then we validate something. And each of these activity, we can go through the we have to release in a more incremental way. First we develop spec, we create the spec, develop something, validate, and then release as an initial version, and then go back again, get the feedback, create the intermediate version, and then deliver the final version, that kind of thing. So this is more like incremental software development. When we talk about the initial version, intermediate, and the final, you can think about people call, what is that, like beta version, alpha version, we can name the version like this as well, okay? That's the incremental software development, okay? There are some benefits and some problems as well, right? Okay, first, the cost of the change, okay, is reduced because we adopt to change now, right? And it is much easier to get the client feedback as well. The software delivery and the deployment process is much faster, and then the customer will see the final the initial working product as soon as possible as well, because in the waterfall there's no different versions here, right? The traditional waterfall, we just deliver the final version, but what happened is that the final version may not be the version that the customer actually want, so that will create lots of problem at the end. Okay, yeah. So incremental reduce the cost of the requirement change and everything, but there are some problems with this process as well, right? So this incremental process is not really visible. Managers need regular deliverables to measure the progress. Okay, so if systems are developed quickly, it is not cost effective to produce documents that reflect every version of the system as well. So again, incremental software development, it becomes a little bit harder to have like a detailed documentation, because they are more focusing on the working software products, right? Yeah. And that's the downside. It's a trade-off. We cannot get everything. Okay, speed or the detailed documentation. So it's a trade-off. That's why based on the incremental software development process here. Okay, in 1990 something, they create the agile methodology. Okay, to reduce the delivery time for the working software system. Right, it is quite suitable where the client is not sure about what would be the system specification. Think about the first day, like startup company. Hey, I want to develop an AI software system. Hey, that can predict the health. Okay, the health of everyone. Okay, for the humanity whatsoever. And then, okay, what is the detail? I don't know, that kind of thing. And then it requires lots of iteration to refine everything, right? That's why agile is quite suitable here. Yeah, so it is the they really focus on the working software system rather than the detailed documentation, blah blah blah. We will talk about the agile manifesto later as well, but this one, agile methodology, is actually based on the incremental software development, but the difference is that it works as a iteration. Okay, it is a series of the iteration, and they really has little focus on the documentation. They really want to focus on the working code, working products, rather than the documentation. And to use the agile methodology, people often use Trello as a tool to facilitate the agile process as well. Yeah, and yeah, we will talk about the agile next week as well. This is the agile manifesto. What does it mean? Okay, manifesto, this is like a key core values of the agile. Okay, these are the four. Okay, first, individuals and interactions over processes and tools. Okay, they really want to focus on the individuals and the interaction among the teams, among the software engineers, right, rather than the process and the tools. It doesn't mean that for example, okay, this is a company, we use this tool, we use this tool, and everyone must use this tool heavily. Not like that. Agile will not focus on that, right? We focus on the individuals and the interactions. Okay. Second, they focus on the working software over comprehensive documentation. Sometimes we really want to focus on the final product. Okay. We want to make sure that the software works correctly, but the documentation, how the class diagram look like, maybe has little attention there. Okay, we focus on the customer collaboration over contract negotiation. Customer collaboration means that when we develop the software, it is really for the customer, right? Customer are the end users, and if we develop one software system but no one actually use it, it becomes very, very useless, right? So that's why customer collaboration, get early feedback, is really important. Okay, to make sure that the software that we develop is actually useful and acceptable by the customer. All right. And the last manifesto here is that we have to be responding to change over following a plan. There's a waterfall, right? This is a strictly rigid concrete plan. There's a waterfall, but they do not respond to change at all. The requirement change, which is not good, right? In real world scenarios, everything changes all the time. Okay, so we need to be responding to change. There's a uh, video here, which is very good. I'm gonna open it and let me know if you can hear the sound or not, okay?
So, it was 2001, and a group of software visionaries gathered at a ski resort to share their experiences and figure out why so many software projects were failing. This wasn't just about documenting best practices. They knew the industry required a fundamental shift in values, and so the Agile Manifesto was born. A declaration of 4 bold value statements that became the basis of a new approach to software development and would change the industry forever. But what were those 4 values, and why should you care? Let's take a look. But first, it is important to point out that the Agile Manifesto ends by noting that all of the things mentioned are important, just that some things must be prioritized over others. Okay, here we go. Number 1, individuals and interactions over processes and tools. This doesn't mean throw processes and tools out the window. It simply means that a good face-to-face chat should trump rigid workflows and impersonal forms of communication. Number 2, working software over comprehensive documentation. Makes sense, right? But traditional software development often produced extensive documentation before a program was released for initial testing. Some documentation is good, but wouldn't it be better to have the program than a book describing it? Number 3, customer collaboration over contract negotiation. Sure, you'll want to start out with some initial guidelines, but instead of locking customers in a cage by defining the exact details of the project before it starts, teams and customers should collaborate to find the best solutions. And finally, number 4, responding to change over following a plan. Nothing ever goes entirely according to plan. So instead of sticking with something that isn't working, it's much more effective to make adjustments as your situation changes. Following the values isn't always easy, but when you build them into your team's processes, customers notice, and the payoff is huge. Which of the Agile values do you think is the most important?
Right. Okay. Yep. So that's the short summary of the Agile Manifesto, and it is really important, right? Now, I'm gonna go through the details of the Agile, okay, methodology. Basically, Agile is the just a general principle, general methodology, and that's the full manifesto, right? But to execute it, there are 2 frameworks, okay. The first one is called Kanban, and the second one is the Scrum, which we will use within the unit, okay. So the Kanban, basically, it is originally from Japan, and it means card, okay. And the purpose of the Kanban is to visualize the work as a card in the board, okay. And this is to understand what the flow of the work, to understand the flow of the work, and try to limit the work in progress as well, in order to maximize the efficiency, right? And the goal of the Kanban is to reduce the time taken to take a project from the start to finish. Okay, I'm gonna give you an example. All right, maybe I will get the annotate. Okay, so first, let's say if you create a backlog. Back a little bit. Okay, so Kanban. This is a Kanban board. This is an example. When we use the Trello, and these are the 4 columns. Okay. And each of the cards represent the task that you need to do, okay? So in the backlog, this is like a to-do list, okay? These are the things that you need to do. There are so many things, you know, and then once you are working on something, you move the card to the to-do list, okay? No, so not in the to-do list, sorry. Move from the backlog to the to-do. This is you are going to do, okay? D is the to-do, and then once you start working on it, right? You move to the ongoing. B and C, this is something that they are ongoing. Work limit here, it means that, you know, within a day, you can work, let's say, only 3 things. And these are the limit, right? And then by the end of the day, you can visualize like how many cards or how many tasks that you have already complete. And this is like how you build the pipeline, and managers can actually view this kind of Kanban board as well, right? In the higher level, like, you know, what are the things that you are working on, what have been completed, and what are the rest of the things that you are going to do, that kind of thing. Does it make sense? Okay, that's the purpose of the Kanban board. it aims to visualize things, focus on the flow of the work, okay, not the other thing. Okay, the next framework is called Scrum. Okay, it is the Scrum. The Scrum is a framework that helps teams to work together to deliver, sustain complex product. Okay, everything is divided into the time frame. What it means is that, yep, I need to click. Yep, move this one here. Maybe move to here. Draw. Okay, so when we work on the Scrum process, right? Normally we start from the vision. Okay, this is a general idea. This is the high level products. What is the vision? What is the goal of the product? What is the objective? And then we define what are the features, the functionality, create the user stories. And then Scrum works as a sprint. You know, each sprint lasts for 2 to 4 weeks. For each of the sprint, we need to create the sprint backlog here to identify what are the things that we need to do for each of the sprint. Once we start the sprint, then it lasts for 2 to 4 weeks. Okay, every day we can have like a daily stand-up meeting to have a catch up. Hey everyone, how are you doing? What have you done? Are there anything that you are going to do? What have been completed? What went well? What can be improved? That kind of thing. And we work as an iteration like this, right? Let's say we complete 4 iterations. No, sorry. For each of the iteration, we need to deliver some working software products here. Okay. Yeah. And that means every sprint we have some incremental working software products over the time, and by the end of the project you will have like something which is very good. Okay, yeah, tick all the box that requirement need, that the customer need. Okay, that's the two difference between the Kanban and the Scrum. Okay, Kanban focus on the flow of the work. Scrum is like sprint. We want to deliver something as soon as possible, yeah, within the sprint. All right, another model is called open source software development. This is widely used at Microsoft, at Google, you know, Mozilla, and these are some of the products, right? Open source software system. Think about Mozilla Firefox, Google Chrome, Android operating system, Linux, Ubuntu, that kind of thing, right? Operating system. And the open source here, the model here is that they have a team actually build an initial version of the software system. Okay, and then they make it available on the internet, right? And then they just open the repo. Okay, and that means everyone can create a pull request, create a new version of the software system, and then they can co-develop that software system as well. And that's why the new feature is created. Okay, and the key point here is that individuals who work with the open source software development, they work as a volunteer. They don't get paid. Okay, but the key goal, the key motivation here is that they create new features or improve something that millions of users actually use it, right? So that's the key impact, the impact that an individual had on the society. Okay, and there's no standard life cycle model. Okay, it really depends on the process. It really depends on the project. Yeah. Yeah. All right, then okay, any questions so far? Otherwise I'm gonna do some another poll everywhere again. This is just to check whether you have a clear understanding of the the learning content that we have today or not. Okay, so everyone just go to the fit513 polev.com/fit5136, or you can scan the QR code as well, you know. So the next question is activated. Let me see. All right, the first question is, okay, what is the primary goal of software engineering? to develop software quickly, to develop software cheaply, to develop software efficiently and reliably within the budget constraint, to develop software with the most features. Okay, so we have right now 16 students answer this question. Maybe next time I should try to set the timer and maybe do some, like, you know, leaderboard who would be the champion of every week. Okay. All right. We have 23 response now. It was 23, but now 22. Someone just removed the answer. Why? Okay, but anyway, this is really about to check your understanding, and it is very good, right? That means if you got it wrong, then I can clarify immediately. Yeah, and then you will not forget. Okay, let's see the response. What is the answer, right? Okay, very good. Congratulations, everyone got the answer correctly. Yeah, so the primary goal of the software engineering is to develop software efficiently and reliably within the budget constraint. Okay, that's the correct answer. And everyone got it correct. Wonderful. Next, next question. What is the waterfall model in software development? Yeah, what is that? Is it activated? Let me see. Double check again. Yep, that's correct. Yep. Okay. We have got yeah, 12 response so far. Let's try to get something over 20 response and then I will review the answer. Okay. So what is the waterfall model in software development? Iterative incremental approach, linear sequential, flexible adaptive, reactive, and unplanned. Woo. Okay, 20 response now. Okay, I'm so excited. Just want to because I don't know whether everyone will get the 100% correct answer or not. But 3, 2, 1. Let's see the response. All right. What is that? Response. Okay. Majority. Okay. So the correct answer should be the linear and sequential approach, right? Okay. Waterfall is actually not the flexible at all because it's not adapt to requirement change, and it's not adaptive as well. Waterfall, is it iterative? No, it's one sequential, one flow, and then all done, right? When they release the software, then once they the waterfall reach the final step, then we cannot go back to the beginning. Yeah, so it's not iterative, it's not incremental. What is iterative and incremental should be agile, right? All right, thank you. Next, yep. What is the primary goal of agile software development? Oops. Okay, I try to aim for 20 responses. Yep, 3 more. Okay, 20 now, and then I am going to review the responses. What is the primary goal of the agile software development? Strict plan and schedule, documentation and processes, customer collaboration over contract negotiation, working software product quickly. Okay, what would be the answer? 100%? No. Okay. Yeah. So the primary goal of the agile software development, okay, definitely not a strict plan. Yeah, don't answer that one. Someone just changed the answer. Okay, definitely not A. Okay, the plan, strict plan should be the waterfall. All right. Focus on the documentation and processes. No as well. Okay, documentation is really waterfall. Yeah, the waterfall is documentation heavy. Okay, customer collaboration over contract negotiation. This is actually one of the agile manifesto. So definitely one of the answer. Okay, to deliver a working software product quickly. Yeah, quickly, but how quick, right? I mean, at the end, I think the primary goal is not about quick, but it is about we still need to focus on the agile manifesto anyway. Quick but not correct is not the agile as well, right? Okay, so choice D is a little bit gray area. Maybe I will need to fix that one later. Okay. All right, thank you. Okay. Next question. I'm gonna go to the next question now. Okay. What is the main benefits of using agile software development? What is that? What is the main benefits of using agile software development? Is that it allows a more predictable project timeline. It encourages a fixed scope and requirements. Does it focus on detailed documentations and planning? Does it promote flexibility and adaptability? Okay, one more response and then I will review the answer. Okay. Yep, thank you. Thank you everyone. So let's see the response. The answer should be the door, right? Yeah, that's the main benefit. Okay. The main benefits we want to promote the flexibility and the adaptability. Okay. Not the B-boy because agile focus on the requirement no not focus but I mean promotes the requirement change, so it's not about the fixed scope or the requirement at all. Okay. It allows a more predictable and project timeline. Agile is actually unpredictable, right? Waterfall is actually predictable because it is plan driven. Yeah. That means agile is not really predictable whether when it will be finished, that kind of thing, right? Yeah. But waterfall is. Okay, next. Next. What is the agile manifesto? First, it is a detailed project plan. Second, it is a set of values and principles for agile software development. Third, it is a type of software testing. Last one, it is a document outlining the project timeline. What is that? We got 10 responses now. Yep, try to get 20 and then I will review the answers. All right, 21 now. Then I will review the answer, response. Yeah. So the answer, yes, correct, 100% correct. Excellent, everyone. Congratulations. Yeah, so Agile Manifesto is a set of values and principles for Agile software development. Okay. Next question. Okay. Yep. Which of the following is not one of the Agile Manifesto values? Okay, which one is not? And to challenge yourself, you should not go look back to the slide at all. Okay, try to remember, try to think about which one is not. Yeah. Yep, 12 response so far. $16. 19. Which of the following is not one of the Agile Manifesto values? Okay, which one is not? Yeah, let's see the response. Most of the students answer following a plan over responding to change. That's right. Okay, let's see what is the correct answer. Should be C, right? Yeah. So, okay, let's go through the option, the choice one by one. Okay. Individuals and interactions over processes and tools. This is the Agile Manifesto. Okay, that is right. But the question asks which one is not. Okay, working software over comprehensive documentation. Yes, it is as well. Customer collaboration over contract negotiation. It is as well. Yeah. So the only one that is not one of the Agile Manifesto values is the following the plan over the responding to change. This is not. So what is the right one, right? It should be responding to change rather than following a plan. Okay. Yeah. All right. Okay. And the last two questions should be very easy. Just want to hear, okay, how do you feel about the lecture today? Okay. Yeah. What do you think? Yeah. What do you think? Yeah. Let us know, feedback is very important to us. I try to, make the lecture as enjoyable as much as possible because this is an online lecture. I try to create the interaction with the student as much as I can. It's not like a traditional lecture hall at all. Yeah. Okay. All right. Let's see the response. Okay, thank you. Looks like most of the students enjoy so far. And what about the what is that? Yeah. Okay. Yep. What do you? Oh, okay. This is actually the last question. What do you like about the lecture today? Yeah. Yeah. Can you try to answer? Let us know. And then if there is anything that we can improve, then I will try to improve it as well. Okay. Can you answer this one or not? I think yes, because I only present the instruction, not the responses yet. Okay. Oh yeah, we have a few response so far. Okay. Okay. So yeah, today is the I will just keep talking while you answer this question. Okay. Yeah, this is a FIT 5136 software engineering unit. It is the core unit for most of the degree, like including Master of IT, that kind of thing, Master of Cybersecurity. And it is my great pleasure to meet everyone here today. And I hope that everyone will enjoy the learning content throughout the semester. If you have any questions, feel free to post on EdStem. If you have questions regarding the admin of the unit, you can send an email to the email row account, and I will try to see the response today. Okay, what do you like? Yep, good pacing, thank you. Okay, yep, interaction part, yep, thank you. Yep. All right. Oh, good. Very good. Okay. Looks like everyone enjoyed the unit so far. And then, yeah, the PPT, yeah, not the PowerPoint, but actually people, process, and technologies. Okay. Yep. Good one. Just still not that sure about how to deal with the assessment. That's right. No worries at all. Yeah, I think the PoEV is very good. There will be more details about the assessment in the next few weeks as well. So if you have any feedback, any question, yeah, don't forget to let us know. And yeah, I hope you enjoy the rest of the semester. Okay. Thank you so much, everyone. Yep. Bye bye.